All right, welcome. Today we're going to tackle a topic that's honestly not just about writing solid code. It's about absolutely acing your next technical interview. We're talking Apex callout mastery, how to build integrations that can actually survive out there in the real world, where things get messy. So let's just dive right in. So, picture this. You're in that senior developer interview, the hiring manager leans forward and drops this question on you, right? This isn't just a coding test. No, no. This is a test of how you think about failure, about resilience, about the big picture, system architecture. So, what do you say? Yeah, this question, it's a classic for a reason. It's not really about the code itself, it's about proving you can build systems that don't just, fall over at the first sign of trouble. The absolute key here is to walk in with a structured strategy, not just like a random list of ideas. Let's build that perfect answer together. Okay, first things first. To really nail this answer, you have to show you understand the problem. Why isn't a simple, basic approach good enough? Let's take a look at what happens when things break, because let's be real, the network always fails eventually. See, a simple callout is just, well, it's fragile. It's basically living on a prayer inside a single try-catch block, hoping the network is perfect. And when it's not, bam, the user is stuck staring at a spinner, the whole transaction just dies, and that's the end of it. A robust strategy, though, it's the complete opposite. It expects failure. It plans for it from the very beginning, running things in the background to protect the user experience and making smart decisions about when and how to try again. All right, now for the main event. This is the core of your answer. We're going to break down a comprehensive 7-part strategy that will absolutely impress any interviewer. Think of this as the blueprint for a truly professional, bulletproof integration. Okay, part 1. And this is probably the most critical step of all. You've got to know when to even bother retrying. Seriously, you don't want your system just spinning its wheels, wasting time and resources trying to fix something that is permanently broken. It's like trying to use a key you already know doesn't fit the lock. It's just pointless. And this table here just lays it all out perfectly. Look, we only want to retry transient issues. Temporary glitches, network hiccups, a 503 service unavailable. That's a perfect example. The server's just saying, hey, I'm swamped right now, come back in a bit. So yeah, trying again makes total sense. But on the flip side, we have permanent errors. Things like a 400 bad request. That means we sent something wrong. Retrying that over and over, it's just gonna fail every single time. So we fail fast on those. Next up, part 2, going asynchronous. This is all about protecting two things, the user experience and your own system's resources. By shifting all this retry logic into a background job, like with queuable Apex, the user is completely unaware. They're not stuck watching a loading spinner. And here's the best part, the big bonus, we get access to way higher governor limits, which gives our process so much more breathing room to actually get the job done right. Okay, so part 3 is all about timing. It's not enough to just retry. You have to retry smart. Instead of just, hammering the external system over and over the second it fails, which, by the way, can actually make things worse, we need to be a little more polite. And that's where something called exponential backoff comes in. It's a fancy term for a simple idea. After the first attempt fails, we wait, say, 5 seconds. If it fails again, we don't just wait another 5 seconds. We wait longer, maybe 15 seconds, then 30. We're giving the other system progressively more and more time to recover. It's a really respectful and super effective way to deal with things like rate limiting or temporary server overloads. Part 4. This one is simple but absolutely vital. You have to limit your retries. Just pick a reasonable number, like 3 to 5 attempts, and that's it. This is your safety valve. It's what stops you from getting stuck in an infinite loop that chews up all your resources trying to hit a service that might be down for hours. All right, and here are the last 3 pieces that tie the whole strategy together. You need state management. You got to keep track of the original data and how many times you've tried. Then logging and monitoring. Log everything, every attempt, every success, every failure. This will save you when it's time to debug. And finally, have a plan for total failure. What happens when all the retries are used up and it still doesn't work? Do you email an admin, update a record? You absolutely have to have a plan for this final failure scenario. So that's the theory. And honestly, just explaining that strategy is probably enough to impress in an interview. But let's take it a step further. Let's look at some code and see how this all comes together in a real-world solution. We're not going to go line by line, just highlight the key parts that make this whole thing tick. Okay, check this out. This little method right here, this is our gatekeeper. This is the code that implements that very first principle we talked about. It just takes a look at the HTTP status code from a failure and gives a simple thumbs up or thumbs down, a true or false, on whether we should even bother trying again. And this line, this is the heart of our exponential backoff strategy. I just love how simple and elegant this is. With each retry attempt, it just uses a little math to double the delay for the next try. That's it. That's how we give that external system the breathing room it needs. Finally, this is how we actually put it all into motion. When a retry is needed, we're not just calling the same method again in a loop. No way. We re-enqueue the entire job and we tell the Salesforce platform, hey, run this again for me, but not right now. Wait until this delay has passed. It is so clean, so efficient, and it lets the platform do all the heavy lifting of managing the wait time. Okay, let's wrap this all up. Let's bring it all home. When you lay out this strategy in an interview, what have you actually shown them? Why does this approach make you stand out, not just as a candidate, but as a top-tier developer? Well, what it shows is that you think beyond the simple happy path. You've proven you build systems that are resilient. They can handle real-world hiccups. They're efficient. You're protecting system resources by going async. They're respectful. That exponential backoff plays nice with other systems. And they're maintainable because everything is clear and logged. That whole package is what a senior developer looks like. Look, this is so much more than just a great interview answer. It's a genuinely powerful pattern you can use everywhere. Once you've mastered how to handle failure gracefully, you've basically unlocked a new level of development. You can now build more powerful, more reliable, and way more ambitious integrations. So the real question is, now that you know how to handle failure, what are you going to build?